All right, everybody. Hello. Wow. This is great to have all you here on a weekday night. My name is Ryan Kalo. I am one of the co-directors of the Tech Policy Lab. I am in the School of Law, and I'm a co-director along with Tadayoshi Kono, who is in the Allen School of Computer Science and Engineering, and Bhatia Friedman, who is in the Information School. The Tech Policy Lab is a unique interdisciplinary unit that spans formally those three units and has co-equal directors as part of our governance. And what we do is we put together interdisciplinary teams in order to tackle very difficult questions about emerging technology policy. We've been around for about 5 years. And another sort of core function of the lab is to bring extremely interesting people to campus like Kate Crawford. So this is actually our Distinguished Lecture Series. This is something that we do once or twice a year where we bring in someone truly extraordinary to address this community. In previous years, we've had folks like best-selling author. We've had a former commander of the, the Chilton, sorry? Strategic Command Commander Chilton. One year we actually had the individual who built R2-D2 for Star Wars and so on. And that's the kind of lineage that Kate is a part of. LaTanya Sweeney was a former distinguished lecturer. But anyway, so we're so excited to welcome Kate Crawford. You can see Kate's various hats that she wears here. She is a distinguished research professor at NYU. She's a principal researcher at Microsoft Research, and she is, importantly for our purposes, the co-founder, along with Meredith Whittaker, of AI Now, which I cannot emphasize this enough. AI Now is simply the most important place that is convening a conversation about the social impacts of artificial intelligence around the country and around the world. Just been an extraordinary force already and is poised to make a big, big difference. I've known Kate for many years now. I think we just realized, we just pieced together that we met at a privacy conference the day that the Snowden documents dropped, which made for some initial really interesting conversations, but we've done a lot of things together since that time. And so I'm delighted to welcome Kate Crawford to speak to you today. Thank you.
Wow. Hello, everybody. This is a phenomenal gathering. Can I just say thank you, first of all, to Ryan for that incredibly generous introduction, but also to many of you here at UW who have got previous colleagues and postdoctoral fellows, and I've also had some extraordinary conversations today meeting with some of the students at the Tech Policy Lab, but also with a range of faculty here. And I just want to thank you for sharing the extraordinary projects and ideas that you have here. I think it's an amazing time to be at this university. So it's a particular honor for me to come and join you and share some of my thinking and research. I also want to say a big thanks to Ryan and to Bhatia and to Yoshi for putting together this extraordinary series. I can't promise R2-D2, but I'm going to do my best. So, basically, to give you a bit of a sense of who I am, my name is Kate Crawford. So essentially for the last 10 years or so, I have been studying the social implications of large-scale data, machine learning, and artificial intelligence. And I think we're rapidly approaching a type of inflection point where these technologies are starting to move into so many of the systems that are touching our everyday lives. I'm talking about criminal justice, healthcare, education, and immigration. And so the question I think we all need to ask is, what role is AI going to play in our lives? And I think the first answer to that is, well, it already is here. It's already having an impact on the news that you see, on whether or not you get pulled aside at TSA, on whether or not you get a job, or whether you get out of jail. So in essence, we're talking about a set of technologies that are already, in effect, participating in our social world. But what does this term artificial intelligence actually mean? Because with something this hype-laden, I really want to back it up and just take a little moment to reflect on what this sort of concatenation of terms is referring to. Because we have to remember that this term artificial intelligence has actually been around since 1956 at the Dartmouth Conference, where a group of men, and yes, they were all men, decided to gather together and try and emulate human intelligence. And since then, we've had these waves of interest in AI, and then we've had these AI winters when everything seemed to not work. But something really changed just in the last 6 years, and we've had this huge uptick in capacity. And why is that? Well, basically, it's around 3 things that have happened. One is really cheap computational power. The second is, of course, just better algorithms. And finally, a vast pipeline of data, primarily being collected by a small handful of tech companies. So basically, since 2012, we've seen this revolution in computer vision due to the advent of convolutional neural networks and deep learning. And I'm going to be throwing terms like this around, but in the end, the most important thing to know is that when people talk about AI, they're basically talking about a constellation of different techniques, of which right now, machine learning is the dominant subset. But AI isn't just technical approaches. It's also a set of social practices, how humans are being classified into categories, how we're understanding the society that we live in, how we're prioritizing the types of problems that we're choosing to work on in labs. All of these issues are also powerfully shaping what AI means today. So we know that now AI is both technical and social. And I see this rise of AI in this current phase as being every bit as significant as the rise of computation itself, or if we want to go back to the rise of mass media in the early 20th century. But amongst the very real excitement about what we can do with these sorts of technologies, we're also seeing what I would say some pretty concerning problems as well. We have forms of bias, stereotyping, essentially unfair decision-making, and this is being found everywhere from machine vision to facial recognition to natural language processing. So how does this happen? Well, right here, I'm showing you a series of images that come from a standard training set that's used in machine learning applications. And training sets like these, which are essentially comprised of thousands of images, sometimes millions of images, are really how machine learning systems are taught to see the world and understand the world. But these sets are made of data that was selected and often just uploaded to the internet by thousands of humans over the last decade plus. So we are training contemporary AI systems to see through the lens of our own histories and of our past. And that can create some of the serious problems that I want to address tonight. So you've likely seen several high-profile stories about bias in AI. You might have heard about the one where women are less likely to be shown high-paying jobs. We found that out thanks to a CMU study. You might have heard that there is gender bias in machine vision data sets, and also that there are now racial disparities in education AI systems. But I want to make something really, really clear from the very beginning of this talk, that none of these issues are new. Ultimately, they're not specific to AI, although I think the scope and the scale is definitely changing. These are essentially technologically amplified versions of existing problems like poverty, unequal access to housing, to credit, and ultimately as well, ingrained forms of sexism and racism. So the legacies of inequality are living on in our digital systems, and they're now being built into the logics of AI itself. So let's take a really recent example. Who here downloaded and had a go of Google's art and culture app? Put up your hand, be brave. Okay, so about half of us. Count me in. So essentially, if you haven't seen this, this was an app that offered to match your selfie to a painting or a photograph from art history. And this was hugely popular. It shot to the top. It was like #1 in the download store. And it was really fun to go, oh, here's my selfie. You know, what does it look like? But it didn't take very long until people started to see problems like this, which was ultimately that some people were being represented much better than others, because Google's art history database, unsurprisingly, was heavily skewed towards Western art, and primarily it was by white male artists. And therefore, women and people of color were getting these much more stereotypical types of representations. But this comes from a lineage of similar errors. This is an example of Nikon's early camera software, which was only trained on white faces, so you can see that it's mischaracterizing Asian faces as always blinking. And then we had Hewlett-Packard's algorithms, which couldn't even recognize people with dark skin tones. And then there's gender bias. So if you do an image search for CEO, you're going to see lots of white dudes in suits. And I just tested this a couple of months ago in the lab, just to see, because I was kind of really curious, like, who is the first female CEO going to be? Make a little guess. Who might it be? Yep, you'd think. Who else? Anybody else? It would be another good choice. But actually, it was CEO Barbie. You can see over here in the bottom right-hand corner. Yeah. Not a great look. And obviously, image results being what they are, these change, but, Barbie's always there in like the top 3 or 4. It's kind of really disturbing. So you can really imagine what it feels like if young girls and people of color are looking up these search terms and they see literally no one who looks like them. So I want you to raise your hand if you've heard about some of these sorts of stories and results before. Yes, okay, my people, this is wonderful. All right, so here's why. I love this diagram. This is by Moritz Hart, who is himself a fantastic researcher when it comes to fairness in machine learning. And as somebody who's been doing this for several years, I have seen this extraordinary thing happen in just the last 18 months. This massive uptick, where initially it was, lol, fairness, why do you care about that, to, oh crap. There is a major problem here. And I think this surge in interest is completely justified, basically because machine learning systems are starting to impact millions of people every single day. So bias matters. And here's an example of all of the leaders in the AI industry who are now starting to say this is one of the biggest problems they face. We've had the head of Google AI, we've had the CEO of Microsoft, and we've had one of the co-founders of DeepMind all say that this is a core problem for the field. But guess what? Science to the rescue. Just as people are starting to recognize the bias problem, we're already starting to see stories like this, that science has cured biased AI. Right. Well, this kind of reminds me a little bit of what was happening 5 years ago, when we were told that data is neutral. What are you worried about? When, of course, it's anything but. Now the version goes, data can be neutralized. We're neutralizing data. And I think while it's incredibly tempting to think that there's going to be a technical silver bullet solution to the problem of bias, it's not going to work. Because here is the problem. Bias in systems is most commonly caused by bias in training data. And we can only gather data about the world that we have. So what that means is that we have a long history of discrimination that is being essentially recognized and reflected by the systems we build. That will be the default tendency of the machines that we build with this sort of training data. Because in reality, the problem of bias runs much deeper than I think is normally admitted publicly. And so that's why I think it's time to start talking about bias in AI as a very hard challenge. Because if we seek out the quick fixes, I think we're not only going to miss the bigger problem, but we could actually start to make things a lot worse. Because structural bias, the kinds of biases I want to talk about tonight, are fundamentally social. So until we start contending with this social history, then these types of bias problems will continue to plague our technical systems. So ultimately, we need to start thinking about how AI is playing a role in our culture. So my talk today is going to address these 5 themes. First of all, what is this bias thing anyway? What are you talking about? Then I'm going to talk about 2 concepts that I'm going to explain in a moment. The first is this idea of harms of allocation, which are the sort of harms that most of the fairness research is currently focused on. The second is harms of representation, which is where I think we urgently need more work. And then I'm going to talk about the big picture, the politics of classification, what happens when we classify people, and then I'm going to end with hopefully some of the things that we might want to think about doing together to address these problems. All right, so what is this term bias? What does it mean? Well, I think the biggest problem that I have with this field is that the term bias has completely contradictory meanings if you're coming from machine learning or law or social science. And this adds a whole bunch of confusion to what is ultimately a very important discussion. If we go back to the 14th century, the term bias emerges in geometry to refer to an oblique or a diagonal line. But by the 16th century, it acquired something like its popular meaning of an undue prejudice. But by the 1900s, bias starts to get this technical meaning in statistics, basically meaning a systemic difference between a sample and its population. So we start to see the idea of selection bias emerge, and then we start to see exactly this sort of statistical meaning essentially be imported into machine learning. Now, who here is in computer science in the room? Give me a sense. Great, so you guys all know this one. This should be like deeply familiar to you. It's basically inscribed on the inside of your retinas. You've seen it so many times. This is the most classic visualization of bias through underfitting on our left. That's when a model is basically failing to capture the underlying trends in data. That happens when there's low variance but high bias. Now contrast that on the right with overfitting. That's situations of high variance and low bias, where models are basically being extremely sensitive to small fluctuations. So it's basically picking up a lot of noise along with the signal. But this is very different to the legal meaning of the term bias, because in law, bias means a judgment based on preconceived notions or prejudices, as opposed to, say, an impartial evaluation of the facts. Now, impartiality, as Ryan knows, is a core value of many of our legal processes, from juror selection right through to the limitations placed on judges to due process, which is something that I've been doing a lot of research on in the past. But this sense of bias is extremely difficult to fix with model validation techniques. And this can happen even when your model is perfectly capturing a signal. So what I mean by this is that you can have an unbiased system in a machine learning sense producing a biased result in a legal sense. So no wonder we have these huge barriers to collaborating across fields, because we're not even seeing the same picture. We're actually using the same word to mean completely different things. But it's precisely, I think, our ability to move across disciplines that we're going to need if we're going to address these problems properly. And let me give you an example why. Some of you have probably heard about the Stop and Frisk program. This was operating in New York City, where basically the NYPD was stopping people on the thought that they could be prospectively engaged in criminal acts. It was running between 2004 to 2012. And what was concerning about this program is that around 83% of the people that they stopped were either Black or Hispanic. So let's just say you use the data set from Stop and Frisk, which by the way is out there and you can download it, and you train a model based on that data. Well, that model is going to tell you that Black and Hispanic people are the people you should be pulling over because they're the ones who are most likely to be engaged in criminal acts. And that is because the system cannot think past its own givens. But let's say you invite some people in from different disciplines. Say you get a constitutional law professor or a historian, and they will tell you a totally different story about a history of racist policing in New York City, which might give you a very different set of questions around how you're going to build that model. So ultimately, I think the social sciences and the humanities have decades of research on bias that unfortunately just hasn't met up at all with what's happening in AI more broadly. And I think we have a lot to learn, because this is where we can start warning people against taking these constructed social categories, like the idea of criminality, and then trying to naturalize it into these sort of essentialized boxes. And I'll talk a little more about that later on. But for now, I'm going to keep using this term bias in its common sense, which means a skew that produces a type of harm. So what type of harms do we care about? Well, I'm going to share with you some insights that come from a paper with some of my colleagues. This is going to be published in the next few months. It's with Solon Barocas, Aaron Shapiro, and Hannah Wallach. And over the last year, we basically just ingested all of the computer science literature that's looking at issues of fairness and bias. And what we wanted to see is how machine learning researchers are conceptualizing this problem. And what we found is that the majority of the computer science literature understands bias as creating what we call harms of allocation. So what the hell is that? All right, so essentially an allocative harm is when a system is choosing to allocate or withhold certain resources or opportunities from particular groups. So this is very much an economically oriented view as it sounds, and it's centered on harms when people are like denied a job or denied a loan or you don't get health insurance. An example here would be, say, if you build a mortgage support app and it continually denies loans to everybody under the age of 30. Okay, definitely we're going to call that a biased allocative harm. But this picture gets a lot more complicated when you look at systems that don't allocate resources. These are called representational harms, and they tend to occur when systems essentially reinforce the subordination of some groups around identity categories like race, class, and gender. And this sort of harm can take place regardless of whether resources are being withheld to members of a protected class. I want to give you an example. Now, LaTanya Sweeney, as Ryan mentioned, was here. She's done this distinguished lecture a few years ago. And she has done this classic early study of discrimination that many of you probably are familiar with. She discovered a pattern of discrimination in Google's ad delivery, which basically meant that every time you searched for an African-American sounding name, you would get ads for criminal background checks. If you look for a white sounding name, you don't get the same ads. So in this paper, Sweeney argues that employers doing searches for job applicants will basically see these results, which will lead to them saying, I'm not going to hire this person because they've clearly got a criminal background. But as much as I think this paper is incredibly important, I'd like to say there's an additional way to think about the harms here. Rather than moving downstream to thinking about, what are your prospects in the labor market, we can actually look at where it starts, because I think representation is really the first step in this chain. So our paper suggests that the perpetuation of stereotypes of black criminality is troubling and problematic, even if it has nothing to do with a hiring context. So it's producing a harm of how black people are being represented and understood socially. So instead of just thinking about how machine learning is contributing to decisions, be that in hiring or criminal justice, I think we also need to consider how machine learning is creating representations of human identity. But you could totally see why allocation has been getting all of this attention in computer science, because allocation is essentially about immediate and very time-bound decisions, whereas representation is this much more long-term process that's affecting attitudes and beliefs. Also, allocation acts are much more easily quantifiable, whereas these ideas of representation are sort of more long-term and they're more difficult to formalize. Ultimately, allocation raises questions of fairness in discrete and specific transactions, while representation is about questions of justice in how humans and society are depicted more broadly. So one is transactional, the other is cultural. So representation bias issues basically get neglected by computer science because it's much harder to formalize and track these sorts of issues. But I'd like to suggest that it's incredibly significant, and it's actually at the root of all of the other types of harms. So, what types of representational harms are there? Well, basically, we look at 5 in the paper, and I'm just going to race through a couple so you get a flavor of what we're thinking about. Stereotyping is probably the most well-known. Now, 2 huge papers, blockbuster papers, came out last year, one by Bullock Bussey and Kalai, one of my colleagues, and the other by Arva Narayanan and Joanna Bryson at Princeton. And they both did, I think, really important work looking at the types of gender stereotypic associations in word embedding. So here you can see in terms of a sort of a spatial model that there are these types of words that are more closely associated with woman versus man. So we have man being much closer to concepts like computer programmer or genius, if you have a look at that one, whereas female is closer to things like homemaker and beautiful and modeling. So yeah, it's pretty normative. But you can see, if you're not someone who's familiar with word embedding, it gets used in a whole lot of systems that you're touching every day. Let's say you try Google Translate. So this is a fantastic example that Arvind has been pointing to. So essentially, if you put into Google Translate in English, translate it to Turkish, which I'd like to point out is a gender-neutral language, okay? So it doesn't have gender-specific pronouns. And you say, he is a nurse and she is a doctor. translate it into Turkish, gender neutral, translate it back into English, she is a nurse, he is a doctor. These are the kinds of shifts that are happening all of the time because of these types of inbuilt forms of bias. Then you have harms of recognition. Now, generally speaking, that occurs when a group is being erased or made invisible by a system. And a lot of the time you'll hear about people talking about technical systems, so a technical system that won't recognize your face, etc. But I also want to introduce, I guess, a more philosophic concept of recognition ultimately as a type of recognizing somebody's humanity, essentially of talking about respect and dignity and personhood. How does that recognition become erased by particular types of systems? That's a much bigger question than just asking if a system works for you. Now, you might have seen a huge slew of stories that blew up 2 weeks ago when Joy Buolamwini, who's a PhD student at MIT, and Timnit Gebru, who is my postdoc at MSR, published a paper called Gender Shades, which essentially showed that facial recognition software doesn't just work better on white people versus black people, but there's also an intersectional question around gender. In actual fact, they're performing much better for fair-skinned men and far less well for dark-skinned women. And this came out of projects that Joy has been doing for years, where she started trying to use facial recognition systems that couldn't even see her unless she was wearing a white mask. So that was really one of the moments where she said, okay, there are some problems occurring here around recognition. Then there's denigration, and of course the all-time classic here is the infamous Google Gorilla example, where Google Photos was automatically labeling an African American as a gorilla. And what made this offensive isn't just that it was kind of wrong or that it failed to work, but that it was using this term that has such a long history of being used to demean people. So ultimately, understanding a problem like that goes so far beyond what machine learning can do right now. It's ultimately understanding culture and history. What we really wanted was somebody in the room at Google saying, hey guys, this label is incredibly offensive, and you kind of want to take it out, which is ultimately what they did. But it certainly points to why there's a lot of pressure in thinking about diversity in the rooms where these tools are being constructed. Now finally, under representation, there is a great paper that was actually done by University of Washington researchers right here, looking at how professions are represented in image search results. So I showed you CEO, but have a look at these two. On the left, we have nurse practitioner, basically all women. And on the right, we have physicist, basically all dudes. And what I love about the UW paper is that they basically went and looked at the US Bureau of Labor and Statistics data and said, okay, even in those professions which are really skewed to one gender or the other, it's actually worse in image search. So it's actually taking and amplifying what is already a type of skew and inequality in these professions. So what we do in this paper is basically we created a table so that you can see all of the known bias cases that have been written about against different types of representational harms. And you can see that in the case of something like Google Gorilla, it's a straight up denigration harm, whereas if we look at, say, the Bullock-Barsi paper, you're actually looking at a whole range of harms in terms of underrepresentation, denigration, exnomination, etc. So ultimately, we're trying to create a more granular and, I think, specific taxonomy of harms so that we can open up different ways of assessing and engaging with bias. So here's the $1 million question, or actually many more millions than that. What are we going to do to address these issues? Well, in this paper, we basically look at a range of technical responses that have already been suggested by the computer science community. For example, one of the most common is that we should scrub these sets to neutral. Just basically remove biased data or break problematic associations if you're dealing with something like word embeddings. But we've got to ask which terms are going to get removed and who gets to make that decision. And an even bigger question, whose idea of neutrality is at work here? How do you actually set something back to quote unquote neutral? Because even if you try to make sure that everyone is being treated the same way, how do you deal with the fact that we've got hundreds of years of discrimination against specific subpopulations? This problem also comes up with underrepresentation. Do you go back to demographics? I mean, and again, the UW researchers showed that that's actually pretty problematic. Do you make representations adhere to current distributions in the population, or Do you show the distributions as you would like them to be? Ultimately, do you try to say, hey, we want a more equal and diverse society, let's get our image search to reflect that? Well, this is actually a really hard question, because ultimately correcting for bias in either of those ways is an intervention. You've made a decision about what you want the world to look like, and that is actually coming from a very kind of political framework, I would suggest. And I think we need to think a lot more deeply about what is being optimized for in machine learning systems. I once, in fact this was quite recently, spoke to a computer scientist who said to me that all they wanted to do was to make risk scoring algorithms in the criminal justice system more efficient. They're like, this could just be faster, we could be doing this in a much simpler way. But there is a risk here that you're ultimately just optimizing for unfairness. You're making systems better at entrenching inequality. So what if this whole focus of making machine learning systems more fair is actually preventing us from looking at a bigger issue? The fundamental ways that we need to, say, rethink the criminal justice system and cash bail, or looking at the sorts of core features that are in essence not technical questions at all, but how we want society to work. So in short, while these technical responses I think are incredibly important, and we actually need a lot more of them, they're not going to get us all the way to addressing these representational harms of human identity. Because ultimately these representational harms, I think, exceed the scope of individual technical interventions. We are, at root, talking about how we want to represent our culture. And I think that requires a different theoretical toolkit, one that essentially technical systems cannot address alone. And that is the bigger issue that I want to talk about today. The big one is classification. Because currently the most common approach to thinking of bias is that it's a type of pathology. It's like an error that just keeps turning up that can be fixed. But what if bias is actually a deeper and more consistent feature of classification itself? In other words, what if bias is always going to be a problem? It is an artifact of classification and is actually more of a feature than a bug of how AI works. Let me unpack that for a second. AI has ultimately supercharged our ability to classify the world that we live in, people and things, using unprecedented amounts of data and learning algorithms. And classification is at the heart of what it means to be doing AI today, whether you're basically grouping text that a user wants to select, or you're classifying an image as a face, or you're putting people into a different type of credit pool if you're assessing risk in a financial system. But we need to consider what is at stake when we classify people, not simply about potential technical errors, but also about this social practice that I think has very real consequences for the people who are being classified. Ultimately, there's just 2 points I want to make here. The first is that classification is always going to be a product of its time. And the second is that we are currently living through the biggest experiment of classification in human history. So let's say we want to understand this concept of classification. And to go back, we can go all the way back to the beginning, to this guy in the blue, Aristotle. Now, his work on natural classification was revolutionary at the time, but has basically now become standard common sense. He went out into the field, he observed living things, and then he came back and made general conclusions. That is basically what we now call the inductive method of empiricism. But from really early on, we start to see how classifications also reflect the social order of the time. This image here is basically from around 300 years after Aristotle, and it comes from a zoological illuminated manuscript. So when you tell people you're at a talk on AI and you're looking at illuminated manuscripts, you can blame me, that's my fault. But what I love about this is that this is meant to be basically classifying animals. But if you have a look, you can see this sort of Christ figure in the background, and the animals are moving 2 by 2. And basically, it's combining religious ideas with this idea of zoological classification. So this history of classification shows us time and time again how attempts to classify always reflect the social, cultural, and political frameworks of the time. Now let's fast forward to the 17th century, where Thomas Urquhart proposes an entire artificial language, which is called the Logopandensian. Now, the interesting thing about the Logopandensian is that he decided in building this that there were 11 genders. Okay, so there's a gender for gods and goddesses, for men, for women, for objects, for animals. And essentially this was a very, complex classification of gender back in 1653. Let's fast forward to 2017. Facebook says there are 56 genders. This is, a pretty precise number. And of course, if you go back just 4 years ago, Facebook said there were only 2 genders. So we've gone from 2 to 56 just in the last 4 years, in case you didn't notice. And of course, I would say this is a great improvement. But it's coming out of the fact that Facebook got a lot of complaints, and they had to try and think what to do about it, and they came up with a pretty arbitrary list. And you know that these things come out of product meetings where people sit in a room with a whiteboard, and they basically write up as many gender identifications as they can, and they think that they've basically solved the problem. Okay, here you go, you've got 56, pick a box, and you're good. But what I would suggest is that they could have actually done something very different. You could have actually had a free text field where people could have chosen their own way to describe their gender identification. You could have had no gender identification at all. But each one of these choices has lasting implications and powerful social effects. And let me show you why. Consider facial recognition AI systems. So this is one of the most common training data sets. It's kind of like what's called a benchmark training data set called labeled faces in the wild. Now, what's interesting about labeled faces in the wild is that it is around 78% men and 84% white. So they are the people for whom systems trained on this will basically work the best. But have a guess who the most represented face is in labeled faces in the wild. Who's in it the most? Who would you think? What was that one? Celebrities, yes, it's definitely oversampling from celebrities, but who would be the celebrity who'd be there the most? Celebrity. Donald Trump, very close. It's actually George W. Bush. Yeah, right? Sit with that one for a minute. Makes almost no sense at all until you realize that, of course, labeled faces in the wild was made by scraping Yahoo News images from 2002. Yeah, okay, so that's what we're dealing with. That has become one of these critical substrates of how we train facial recognition systems. So no wonder W is everywhere, absolutely everywhere. There's 530 images out of the 13,000 in this set. Because, of course, the president, much to my chagrin, gets an enormous amount of news attention. So it's a great reminder that these data sets reflect the culture, but also the hierarchy of the world that they're being drawn from. So whenever I look at this, it makes me think of 2 things. The first is, when you choose something like news photography, who are you going to be seeing more often? And what sort of people do you not see? What sort of faces are going to be left out of the news? And then secondly, it always reminds me that the data sets that we use now are essentially built on the shoulders of older classifications. This was a point that was made long before me, back in 1751, in Diderot and d'Alembert's Encyclopedia. They basically classified all human knowledge into 3 domains: memory, reason, and imagination. And if that seems kind of quaint and old-fashioned to you, you should know that machine learning has similarly weird, strange, and arbitrary classifications that are already having an impact on your life. For example, what if we tried to remake this, basically d'Alembert's classification, for AI today? Well, this is something that we just recently have been working on at AI Now, and it looks something like this. What we've done is we've taken the most common contemporary training data sets, and if we zoom in here, we've got people, things, and ideas, the kind of core classifications. And you can see how, you take any one of these sets like labeled faces in the wild. It was building on faces in the wild, which was building on the Caltech web faces, which is all the way back to Ferret, which was being created in the early 1980s by DARPA. So training data sets are already conducting this massive classificatory experiment across everything from human faces to human poses, to actions, to gestures, to objects, to places, to natural phenomena. But all of these classifications and how we decide what they are can have lasting harmful effects, just like this one. This is the cover from the Diagnostic and Statistical Manual of Mental Disorders, which was first published back in 1952, still, itself a core book which is, refreshed very frequently. It listed in 1952 homosexuality as a mental disorder. It took 30 years for that classification to be dropped. And if that seems like a long time, know that the Dewey Decimal System, which is used for basically organizing books in libraries, first lists homosexuality in 1932 under mental derangements. And you know how long it took for that to be removed? Happened just 2 years ago. That's been sitting there to be gay as a mental derangement until 2 years ago. So basically we have this deep classificatory harm where people were being classified as gay and they're being classified as having a mental disorder and being a social problem. And this has devastating consequences for the people being identified, and it's taken an enormous amount of advocacy and work to change that. But I would suggest that those harms continue to reverberate even after the worst labels are finally removed. Because as you know, history is starting to repeat itself. This is the now notorious AI gaydar paper. Who has actually looked at this paper or heard about it? Oh, this is fantastic. I love this room. All right, so this is Wang and Kaczynski's paper. It becomes hugely controversial, basically because it claimed that you could detect sexual orientation from somebody's facial image. And they did that by scraping huge amounts of images from a dating website and from Facebook, and then claiming that they had pretty high confidence bounds in predicting, first of all, whether a guy was gay was around 81%, and whether a woman was gay was around 71%. Correct me if I'm wrong, that's from memory. But this is a deeply problematic study. Now, many people in the scientific community have critiqued it from everything from the way that it's confusing cultural demarkers of how we culturally represent ourselves as gay to mark ourselves out to our communities, to try and say that it's somehow morphological or built into our face structure, that they, of course, didn't control for. But beyond these sorts of, I think, really important critiques, we need to think about the ethics of classification here. Particularly when, of course, homosexuality is itself criminalized in 78 countries, some of whom apply the death penalty. But at an even deeper level, for me, I think at the level of epistemology, there is a core confusion here. And this paper is really good because I think it points out this confusion that we're going to start to see a lot of. It is confusing social and relational categories like gayness with something naturalized and essential, like, say, labeling a chair or a cat. And I think we can see here how easily machine learning is essentially making fluid and complex social and cultural categories fixed and reified. And at the same time as doing that, they could then result in the criminal prosecution or jailing of humans, or in some cases, a lot worse. So I think our responsibility for our classificatory tools has ultimately just never been greater. So I've talked about the history and the ethics and the epistemology of classification, but now I just want to talk about how this connects to social and political struggles. And here I really want to name check Jeff Bowker and Susan Lee Starr, who are key thinkers on these questions. They looked at apartheid South Africa, and in particular this, which is called the Book of Life. Now, the Book of Life was essentially an information system that categorized everybody in South Africa into one of 4 categories. You are either colored, ooh, whoa, dramatic fall, I love it. That was beautiful, thank you. I'm gonna see if I can do without it, and we'll keep going. That's very good, woke you up, right? You are either colored, Indian, white, or black. I really smashed this one, that was great. And ultimately, this decided a whole lot of things about your life. It would determine who you could marry, what job you could have, where you could live. And it was also really oddly determined. They decided what category you were in based on your appearance and your general repute. So try and think what could go wrong there. This is a very famous jazz musician called Vic Wilkinson. And he was recategorized in this system 5 times in the course of his life. So each time changing where he could live, what sort of jobs he could have, completely disrupting his family. And ultimately, as Bowker and Starr show, this type of really arbitrary classification, I think, shows the really deep instability of all of the social categories we've been talking about tonight. Criminality, gayness, etc. That all of that fluidity is lost in a technical system that seeks to fix you into one category or another. Fast forward to 2016, when Wu and Zhang's paper comes out claiming that it could predict the likelihood that somebody would be a criminal based on nothing but a picture of their face. Now, they claim that this is a form of bias-free criminality detection. And I'm pretty sure that I found the algorithm that they were using. It looks a bit like this. You take untrustworthy data, shove it through a deep neural net, and out the bottom, infallible results. It's such a good one. Of course, I'm being a little bit cheeky here, but ultimately they are making this type of argument. Because nothing could be further from the truth than to say that this bias-free criminality detector doesn't itself construct this social category of criminality, which is disproportionately given to people in marginalized groups, and then claiming that it's somehow physically inherent. That is a massive red flag to me, that this is not free of bias. This is just bias hard-coded. And of course, all of this type of face-based prediction has happened before. Phrenology and physiognomy, those debunked sciences, pseudosciences of the 19th century, had this particularly nasty history of being used to justify the unjustifiable, from slavery to the race science of Germany in the 1930s. But if all of this sounds like weird history to you, you should know that there are currently startups who are making money saying that they can predict from somebody's face whether or not they will be a terrorist. This is faceception. And as you can see, it should be exactly no surprise that it's the slightly Arabic-looking guy that is the terrorist. So these claims of predicting if somebody is gay or a criminal, I think, should be deeply suspect to all of us, because I think there is a fundamental epistemic confusion at the root. Moreover, I think these papers are being released at a time of rising political populism, when many people in power would love nothing more than to have a completely unaccountable system of classification and control. And as one of the founding fathers of cultural studies once said, it's when classification becomes the object and disposition of power that we really need to be concerned, because these classifications will determine who gets advantages and who will be deprived. So what are we going to do about this, guys? This is a big and I think a pretty gnarly problem. And how are we going to ensure that AI doesn't reproduce the damaging social effects that we've seen in these classification systems of the past? I'm going to talk about three paths forward, from the most narrowly scoped, I think, to the biggest. So let's begin with this one. Basically what I'm calling fairness forensics. I think we really need much stronger mechanisms for assessing, understanding, and intervening in algorithmic decision-making systems. Now, this can include everything from pre-release trials. It kind of baffles me that a lot of these complex systems are released into the wild without ever going through extensive pre-release trials. We also need to do monitoring once the system is released in the wild to see if it's affecting some populations differently. And we also desperately need some kind of standards for the life cycles of training data sets, like labeled faces in the wild that I showed you is actually a really good example, because Leonard, who created it, painstakingly writes up every paper that uses it. But we do need these standards of measurement that will essentially start to think about different types of representational harms, because only then will we know how something is working and how it might be failing. Another thing we've been working on at AI Now is algorithmic impact assessments. You might have heard that New York City is the first city to be building towards an algorithmic accountability bill, and they have a task force which is about to be announced in a few weeks that's going to be addressing these questions. So if you're interested into some of the recommendations that we've been making, all of this is online, and there's lots more to say here, but I think we should move to the final stage of the night. I'm keeping you from drinks, so let's keep moving quickly. The second big area is that I think we need to connect across fields. You might have noticed that I think interdisciplinarity is definitely one of the things we need more of. Ultimately, we need to work with people who are studying harms in form of bias well beyond the technical into the socio-technical. That also means prioritizing diversity and inclusion across the board. Ultimately, that means if you're working on a high-stakes system that touches something like criminal justice or education, that you go and work with domain area experts, especially those people who have strong ties to the affected communities. So we don't just have people rolling into the top and saying, hey, we're going to fix your problem, and then rolling out of town and then leaving it there and gradually finding that it has these systemic issues. Towards that goal of increasing interdisciplinarity in this space, and certainly taking the lead from the Tech Policy Lab, who I see as like a shining light in this space, I've been working with my colleague Meredith Whittaker to launch the AI Now Institute at NYU. And ultimately, the reason we did this is because I don't believe that in the current way that we have these labs constructed, that we could look at these problems in a single disciplinary home. We ultimately are now supported across 6 different faculties and schools, including computer science, engineering, law, business, data science, and social science, to really start to construct large-scale studies to understand the social implications of AI. And ultimately, I think this is a really urgent problem. And if you would like to be part of this sort of work, by all means, contact me and get in touch, and I can tell you more about how to be involved. But finally, I think we need to think a lot more about the ethics of classification. And the big question here is, what is the AI industry's responsibility? What tools will actually enable self-determination, but what should we not build? Like, what should we say, no, this is too far, we need to have a bright line? This is actually an incredibly important question, and it's a muscle many of us are not used to flexing, but I think it's something that we need to consider. And it's going to become ultimately much more important as the tech industry seeks to professionalize fairness and to hire people in-house to try and patch some of these problems. Now, in some cases, they could be hiring people to just come up with very narrow technical fixes to avoid lawsuits under discrimination law. But what I would like to think is that they will actually start looking at the very least at these much broader harms that can occur when we start to allocate people into reified identity categories. At the biggest level, I think we need to start to think of a different way of evaluating AI systems and to use them in a way that serves us. The rapid expansion of AI is often seen as this kind of inevitability, like this sort of octopus that's just going to move its tentacles out into every single part of our lives, and the most we can do, the best we can do, is to tame it by creating these zones of exclusion, like some privacy over here, and if we're lucky, some kind of consent rules over here, and if we're really lucky, maybe down the track, something like data ownership. But these are always, I think, really partial and incomplete ways of how to think about these systems. What would happen if we completely reversed this arrow? If we went the other way and we said, what type of world do we want to live in? And from that, we backed out the question to say, how does technology help to serve that vision? Because ultimately, I think we need to ask ourselves, what kinds of power do our existing technologies amplify and optimize? And do we want to amplify those forms of power? Or can we imagine something else? So as we move into this increasingly AI-driven world, I think it's important for all of us to remember that it's all still being driven by humans, which means that we all collectively have the ability to resist, to change, and ultimately to imagine new worlds that we want to inhabit. Thank you.
You mind taking a couple questions?
Yeah, we can take questions.
Yeah, if folks have questions, I think we have a couple of microphones set up on either side
Yeah.
here. So if there's a couple of
okay.
questions for
there's one just there.
I think there's one,
just
just there, and maybe one on the other side too. Thank you very much.
And we finished on time. It's like a miracle.
It is a miracle.
Just raced you through everything. Great. So who's brave? Hi. You may need to speak loudly if the mic isn't working.
There we go.
I can hear you. Wonderful.
Fantastic talk. I wondered if you could comment on whether there might be a distinction between what I'll call sort of final decision-based classification, you get a loan or you don't get a loan, versus these sort of proxy classification systems that sort of come as an intermediate effect in order to sort of simplify those final decisions. So in the case of like the DSM, ultimately you're going to administer some treatment or you're not going to administer some treatment. And so the book was really developed as kind of a shortcut to help people do that. And they screwed it up and got it wrong in some of the ways that you named. But I wonder if we're sort of moving toward a world where we don't really need those intermediate steps so much that cause all that harm, because we can go directly from data to final decisions. Or am I all wet?
I guess let me ask you this. Do you think we can go directly from data to decisions, or do you think there's still a series of kind of complex heuristics that we're going through? Because I've yet to see a system that goes directly from data to a decision without someone deciding how that decision is made.
I think we can. But I may be alone.
Just checking. No, because I think that's the point. I think the issue is that we look at things like the DSM and say, oh, we're so much more sophisticated now. For example, some of you might have heard that there's a study that was done looking at your Instagram posts and basically trying to diagnose mental illness because of the photos that you take and the color composition. Like, is this person depressed? Your photos seem really gray and boring, and maybe you should see somebody about that, right? But what I find really troubling about those kinds of studies and ultimately types of tools that are being used and hopefully, in some cases being critiqued, is that they come from this place where is the evidence for thinking about the kinds of clinical practice that we're assuming in those studies?
But even in that example, that's an intermediate classification of this person has a mental illness or doesn't.
Yeah.
They're not about to act on that decision. At some point, there's a necessary classification at the very end of the road where somebody says, "Am I going to hand them this pill or not hand them this pill?"
Yes.
That's you can't get away from that kind of classification.
That's right.
And so what I'm suggesting is skip that. That's another example of one you can skip. Don't try to classify them as either having a mental illness or not. Try to learn what is going to actually help that particular person's outcome or not.
How do you do that?
Well, by getting enough data.
Aha! I know where you're going now. This is exactly the question that we face a lot. And I face this a lot, and in fact, it was interesting that we started this evening with Ryan's comments around Snowden, because if you have perfect surveillance, you could do that. If I knew everything about somebody, if I have a complete capture of all of the data in your life, you're absolutely right. I don't need a heuristic. I don't need to see your Instagram posts. I'm going to know if you're depressed because I have cameras everywhere. I know exactly everyone you're speaking to. I know exactly what you're writing down. I will have the best ability to diagnose you. But is that the world that you want to live in? That's the question that I think is at the heart of certainly some of these issues around classification. Because you're absolutely right. We could start to have something like perfect information about people, but we have to ask very carefully what we give up to have that world. And the closer we get to that world, I think the more concerned I am. But it's a great question. Thanks. Someone over here? Yeah, you just have to turn the mic on, I think, at the side.
Thank you. Great talk. My question is how we think about the questions that you're posing in terms of what type of world we want to live in, given the unique geographic context in which AI is being developed.
Yeah.
So I noticed that most of your examples, for instance, are of companies that are based, obviously, in the US. Most of your historical examples around classification are related to Western culture and the development of Western civilization, or at least the spread of Western values to other parts of the world. Yet when it comes to artificial intelligence, a lot of the developments occurring in cultural contexts that aren't uniquely Western.
Yes.
Which means that the classification systems are going to be different.
Yep.
In some cases, it's also being backed by governments with very different visions of the world than governments in the past or companies that you referenced. And so I'm wondering how you think about having this conversation not only across the Atlantic, but across the Pacific as well.
I love this question, and I think it's incredibly important. I would note that several of the examples that I used tonight were created by labs that were not in the US and were not in sort of the West as it is constituted. And certainly the sort of the criminality detection paper is coming from China, et cetera. But you point to a bigger and I think really important question, which is that we're moving into a phase in AI development where there is an enormous geopolitical rift between what is happening in the US and what is happening in China, and then what is happening in the rest of the world, which in many ways is being construed as a type of just like series of client states. Because if you look at the countries that are spending huge amounts of resources into really driving the AI industry, it's really the leading two are the US and China, and everybody else is a long way behind from that. So then we have to start asking questions about sort of different cultural histories, different values, and different structures of government. And what happens when you have highly centralized governments like the ones in China saying, okay, AI is a priority, we intend to lead the world in AI by 2030, which is a publicly stipulated mandate, and they have the ability to then say, these universities are going to work on these problems, these companies will work on these problems, etc. Now, the way this gets painted commonly that worries me a lot is that somehow China is the big bad guy here, and oh my God, they've got the Chinese social credit score, the Sesame credit scoring system, and it's terrifyingly authoritarian, and we could never have anything like that here. In actual fact, a lot of the sorts of things that are happening inside things like the social credit score in China are also happening in the US. We were talking just last night about, of course, the Facebook patent that you could get credit, you could get a loan based on the people that you're friends with in your social network. And that if your friends are wealthy, you can get a loan, but if your friends are poor, then sorry, you don't get a loan today, right? So it completely changes how you think about who you befriend, how you perform identity in public. So I'm actually concerned about, to some degree, I think there are cultural variations here, but I also think there are a set of shared problems that are coming across these two domains. Now, it's really very, very early, and I'm not in a position, as somebody who hasn't spent a lot of time studying the Chinese AI industry, to say what those shared concerns are. But from what I'm seeing across the product development world, I'm having concerns about both. It's not as though I'm saying, oh, well, in the US has got this figured out, this is fantastic, but China's a problem, or vice versa. I think what we're seeing is a set of issues that are replicating across systems because of shared problematics. But it's a great question, thanks. Hi.
Thank you for the excellent talk. Oh, are you next?
Over here?
Thank
Brilliant,
you.
hey.
I don't know the last time I saw illuminated manuscripts and Diderot's encyclopedia in the same moment.
It is my pleasure to bring them to you.
I really enjoyed that. As an academic, as a graduate student, I'm here all for these ideas of thinking about ethics, thinking about what should we not build, how to make our AI better. But I'm also worried about the money is power sort of thing, that the folks who are currently benefiting from these classification systems are the ones who have the money, and they have the power to say, we want more money. And so how outside of academia, where we've decided that we pursue lofty goals for less money than we otherwise could, do we convince folks to give up some of their power, some of their benefits from this unfair system?
Yeah. This is a really good one. And it's, again, the sort of conversation we would probably have over multiple beers. But let me give you one version of this. You are absolutely spot on. What you are seeing right now is the biggest feeding frenzy in the AI industry to hire people out of academia. So this is a very big problem in the sense that academia has just lost a whole tier of its sort of big leaders in machine learning, for example, that have just all gone to industry. And it's concerning because, of course, we already have a highly concentrated AI industry. It's a small handful of companies that can really do this at scale. So I think academia has a real problem in saying, hey, we're going to pay you less. You aren't going to have the same massive data sets to play with. Oh, yeah, and all of your colleagues have left. But hey, stick around. This is a really hard case to make. So I actually think it's incredibly important to start thinking about what is it that universities do that you cannot do in industry. And this is actually part of the stuff that I think is really important in terms of things like why we constructed the AI Now Institute in the first place. Because I think universities are still the best places to go if you want to understand these systems at scale and you want to critically intervene. If you want to change the way that people are thinking about these systems, if you actually want to say, hey, here's how things might actually be going wrong, Or if you actually want to do the kind of work that I hope many of you do, which is to do empirical research, essentially understanding these social implications directly. Very hard to do that inside technology companies as they're currently constituted. Actually, in academia, you have an enormous amount of independence, criticality, and freedom of speech where I think this work can really happen. But it's going to be hard, and I think it's really important not to kind of gloss over the fact that we're talking about a lot of money and a lot of power being centralized in a very small set of industrial spaces. It's a great question.
So on a related note, and maybe following up a little bit, I've sort of maybe pessimistically decided that some of it comes down to economic sustainability, and the people who have the resources to work on this are the people driving it.
Yes.
What are your thoughts on how should we break that cycle, or is there some sort of economic incentive that we might think about?
So do you mean an economic incentive for companies to think about this differently?
Yeah.
You mean like,
the
say,
idea of,
regulation?
whether it's
That's
regulation
a
or
pretty
something
big
else.
incentive. Yeah. Are you talking about are you talking about market-based incentives or government-based?
Yeah, to some extent, the idea that people are optimizing for profit as the metric of interest and maybe not social well-being.
Yeah, absolutely. Well, I think that's absolutely fair to say. And look, there's a long answer, which we could go into the history of the corporation and corporations getting the status of persons and the fact that companies really have a prime directive, which is to increase shareholder value. And that means, yes, they are going to be motivated by profit. That's what companies do. And it's actually extremely difficult to try and give them a different set of incentives unless you have things like best practices where there's forms of social shaming and the likelihood that people will stop using your service. That's really hard to say in systems like this, where in many cases, you're not even aware that you're actually feeding an AI system, or you may be reliant upon it. I mean, we could here talk about phones, Facebook, et cetera. But the other thing is regulation, and I think regulation is being discussed seriously for the first time in a long time, not because of the US context, for the very obvious reason that there is currently an administration that shows exactly zero interest in regulating anything, apart from the occasional tariff. But we are talking a lot about Europe. And I think what is happening with the General Data Protection Guidelines, which come online this year in May, is the first real substantial step into thinking about what is a way of thinking about sort of a more balanced playing field. Now, we could have a long discussion about whether that's going to be successful or not, and whether those regulations are in themselves representing particular types of limitations. But I certainly think that the industry is going to need to do a lot of work to show that it is thinking about well-being, that it is thinking about best practices, and that it is prepared to implement those best practices even if it means a loss of profit. Because I think that's ultimately what we're talking about here. And I would point to one thing, which is the Partnership on AI. This has just been constructed very recently. It has all of the major AI companies sitting around the table, including a set of NGOs who are then joining them. That is a place where you could perhaps socialize these best practices and start to talk about, look, what is a standard that the industry could start sort of aspiring towards? Because at the moment, let's be clear, there is nothing. There is like no set of like agreed upon best practices. We're really talking about an absolute Wild West in that sense. So I think PAI is partly a recognition of that. And we will see how it goes. But that's a great question.
Thank you for speaking here. A very related question to regulation. So there's the popular saying that software is eating the world, and increasingly what seems to be happening is that consolidation of infrastructure is eating software. You have the popular cloud providers, containerization, virtualization, and these turnkey AI solutions that all of these companies now sell. Do you foresee the same forces that are driving profit-driven forces that have postdocs and graduate students leave CS academia in the same way consolidate sort of the entire information industry into these giant, fairly unregulated utilities that that might develop, and how might someone, an individual technologist, what might someone do to combat this? Possibly something like unionization or similar.
Right. So is your concern here the sort of the acquisition of basically all industries underneath these kind of megacorps and how people might actually deal with that? Is that a fair restatement?
Either by either by buyouts, acquisition, or just the sheer dependence on turnkey AI solutions that are trained on proprietary data sets.
Oh yeah. Well, that's a really big question. I think what you're pointing to, and I'm certainly interested to see what's going to happen when these types of AI systems, and you say turnkey systems. I mean, the other way we can think about this is machine learning as a service, that these are off-the-shelf tools that more and more people are just going to be able to apply. And what concerns me is that, I mean, most of the things I've been talking about today, we know about because academics, researchers, and investigative journalists have noted these issues and said, hey, here is a consumer-facing system. I can see a problem. I'm going to research it. The vast majority of machine learning is happening away from any consumer-facing interface. It's happening in back-end systems that you will never see and that you will never be able to test. You won't even know it's actually happening. So what concerns me there is the fact that we are talking about the tip of an iceberg, which is the visible bit, but the much bigger space is completely invisible to us. So that's what we're dependent on, I think, to sort of get back to your question, which is that we are dependent on systems that we have absolutely no insight into, that we cannot see. And then to some degree, this is part of the reason why at AI Now we've made this, we made a set of recommendations that I just don't think it's appropriate for public agencies who are making decisions like, should someone be cut off from welfare, or should somebody receive a loan, to use systems where you can't even see how bias might be perpetuated. That you, at the very least, need to have auditable systems where you can create some type of impact assessment to see how a tool might affect people. Because that's what really worries me, is the fact that these things are getting applied in spaces where researchers aren't going to know. We're never going to see it. But yes, I could talk for hours about that question, but I'll leave it there. Thank you. I think we maybe have time for maybe one more.
One more question.
Great.
If we could. Yeah.
Hi, Kate. I heard your talk on a podcast, Microsoft Research, and part of the ending of what was there today. So professor of mine sort of quoted an Alaskan study where certain data was recorded from select people, but the decision made affected all the people. So even in public services right now in software, you can choose to submit data that an AI algorithm might use to do something, but it doesn't just affect the people that submit the data. So I feel this is an area where sort of policies could sort of be looked at, and I wanted your opinion on that. And there's a second part of it, which is you talked about biases and the fact that ethics needs to be looked at regarding AI algorithms. To my large understanding, AI algorithms per se aren't the ones that have the bias. And the part that are largely curable is the data that has the bias, right?
So what people have the bias, you
the
mean?
data that is being recorded,
yes,
right?
Sure.
That's the thing that has the bias, right?
Yep.
So, I mean, how do you measure bias like that? And does that sort of sometimes require you to gather more data, which becomes like an infinite loop, to understand what a bias is?
Yeah, let me answer the second part first. You're exactly right that I'm not going to have an easy answer for you for how do you detect for bias in large-scale training data sets. There are studies that I can point you to. There's a great conference that is now in its going into its 6th year called FATML, or now called FATSTAR, which stands for Fairness, Accountability, and Transparency in Machine Learning. There are a lot of technical papers of people trying to begin to answer that question. We are so far, can I just point out, from actually having an answer right now that it's very nascent. But one of the things that I've been working on with Meredith Whittaker at AI Now is looking at one part of that problem, which is how do you think about data provenance? How would you even begin to start to classify where a training data set came from? We don't even have basic information where you could say, oh, well, this training data set was gathered in this year. These are the demographics. These are the people who gathered the data. This is how much they were paid. This is if they were Turkers or they were graduate students. I mean, you can only find that stuff out essentially by painstakingly going back through training data sets. Maybe you read the papers. Sometimes the information is in there, sometimes it's not. So we don't have standards. We don't have basic kind of data provenance standards. That would be something that I would say is a problem we can actually get some traction on to begin to at least start to say, well, oh, this is a massive demographic skew. Maybe you don't want to apply it to all populations, maybe just to these kinds of populations. So they're the sorts of discussions that we urgently need to have, and it's something that I'm really interested in working on, and feel free to get in touch if you are too, because that's a big one. This other question, I think, is really getting to the very big issues around how do we start to think about the way that systems recognize humans. And I cannot underscore enough that I think we are looking at a type of epistemological collapse. That if what we are doing is trying to fix people into ever more precise categories based on what you buy on Amazon, who you talk to, what your pictures look like on Instagram, that we are coming up with these, I think, problematically fixed understandings of humanity that will be very hard to undo, and that ultimately systems cannot be self-critical about. That we will be trying to essentialize and naturalize things that are essentially cultural. And that is where I think our biggest problems are emerging from. Thanks for your question. And thank you all.
Thank you so much, Kate.